You sit down, pull up an AI chatbot, and type a simple question, "Where to purchase a shirt?" And immediately the machine spits back a bland, practically useless list of generic online retailers. So you try a different approach. You drop in a massive article and type, "Summarize this." The AI responds with an impenetrable, dry wall of text that is almost as long as the original document. This frustration stems from 20 years of conditioning. We have been trained by traditional search engines to type fragmented keywords and hit enter, expecting the machine to do the heavy lifting of finding the right link. Applying that same passive mindset to generative artificial intelligence forces a highly advanced system to operate at its lowest possible capacity. The result is a generic, mediocre response. Traditional search engines query a database to fetch existing links. Large language models do not. They are deep neural networks trained on vast amounts of data, and they generate original content by predicting the next logical word in a sequence. Because they operate on probability, giving an AI a vague question forces it to blindly guess at your intent. Left to its own devices, it defaults to the most average prediction available. The way around this is prompt engineering. This is the practice of guiding the AI by providing strict instructions, a clear context, and tightly defined boundaries for how it should respond. Moving past the digital encyclopedia mindset means trading passive questions for active, engineered commands. Consider a highly structured request, telling the AI to act as a sales assistant in Alabama, summarizing local inventory for a blog post. This precision relies on a specific framework. Every prompt starts with a task, using a clear action verb to establish the goal. Next is context, providing the machine with specific background and demographics. Laying down these two elements immediately sharpens the output into a highly relevant draft. Without defining the task in context up front, the model wanders. It has no criteria to determine what success even looks like. The third layer is exemplars. Feeding reference data restricts the model to your provided facts, improving accuracy. Next, assign a persona. Telling the AI it's a senior analyst shifts its behavior, adopting a tailored tone while strictly citing the provided facts. You take a blank slate chatbot, give it blueprints and a job title, and turn it into a specialized worker capable of complex execution. The final layer of control comes down to format and tone. This means explicitly dictating the shape of the output, asking for 3 bullet points, an email structure, or a casual, enthusiastic paragraph. This 6-part anatomy is highly standardized. Microsoft Copilot explicitly prompts users to define the goal, context, source, and expectations. These are the same categories used across the industry to guide performance. Implementing this complete framework drastically reduces the space the AI has to guess. It forces the model into a defined path, ensuring accurate intent. There is a counterintuitive truth to working with generative models. Setting strict limits, word counts, stylistic boundaries, and required vocabulary actually boosts the machine's capability by providing a stable framework for the AI to work within. The process rarely ends with the first output. You read the result, evaluate where the AI missed the mark, and write a follow-up prompt to refine it. This is known as prompt chaining. When you draft these structured, iterative instructions, you are effectively writing code. You are simply using English to do it. In the past, commanding a computer required learning highly specialized mathematical syntax to bridge the gap between human intent and machine logic. Now, the interface is natural language. Mastering the architecture of a prompt gives anyone the ability to program a machine simply by speaking to it.